Hey everyone, and welcome to Dr. Abu Artin Academy channel. In this video, we're going to discuss part 2 of the distribution of random variables in the biostatistics subject. Our focus in this video will be on the mean and variance of a discrete random variable. Okay, we have already taken in the previous videos how to get the variance and how to get the mean, how to get the standard deviation if we have a set of data. Okay, but in this video it's good to understand what we are trying to say here. What we are trying to say, if we have a set of data and we have their probability, and these data are discrete data, so it has unique or discrete numbers. Okay, like 1, 2, 3, 4, 5. It cannot be 1.1, 1.2, or 2.3, 2.5. It is discrete, like the blood groups A, B, and O, but in numbers. Okay, so if we have such whole integer data and we want to find the mean or the variance of them, this is with their probability. So this is the way. So here in this video we'll be discussing the set of data and their probability together, the probability and the set of data, and how we can use both of them to arrive to the mean and the variance of such discrete data. So if you recall in the previous video, if I have a set of data like this one, x equals 0, 1, 2, 3, how I can get the mean of them? The mean of them, which called x bar, okay, will be equals to 0 plus 1 plus 2 plus 3 divided 1, 2, 3, 4. I have 4 numbers. Okay, so divided 4, so it would be equals to 1 plus 2 equals 3 plus 3 equals 6 divided 4 equals 6 divided 4 equals 1.5. So this will be my mean. Okay, the x bar. Okay, if this is the population, we used to call it mu. If it is a sample, we call it x bar. Okay, so it could be x bar in case of sample, or mu in the case of population. Okay, so what about the variance? How we used to get the variance for such case? We said that the variance, which is, let's assume it is a sample, s square, because the variance, I have two variance for the population, which is sigma square, and variance for the sample, which is s square. The variance x square for the sample equals x minus x bar, okay, square divided n minus 1. And in the case of the population, it was x minus mu, which is x bar also, but in the case of the population, square divided n. Okay, this was the definition. So here, in order to get this one, I have to say x minus x, the first x is 0, and x bar is 1.5. So 0 minus 1.5 square. So here it is the sum. Okay, the sum of them, plus 1 minus 1.5 square, 2 plus 2 minus 1.5 square, plus 3 minus 1.5 square divided n, which is 4 minus 1. Okay, so I have done the calculation here in order to save time. So here, as we can see, that s square equals sigma, okay, x minus x bar. So here each x, 0 minus 1.5, 1 minus 1.5, 2 minus 1.5, 3 minus 1.5, and every one of them, the bracket should be square. So 0 minus 1.5 square, 1 minus 1.5 square, 2 minus 1.5 square, 3 minus 1.5 square, divided n minus 1, because this is a sample. Okay, it is not population. So the answer was 1.666. Okay, always the sample, the variance in the sample is higher than the variance in the population. Okay, because here divided n minus 1 and here divided n. So sample always will find it bigger, okay, than the population. So also here the variance, but for the population, for the same same set of data, it will be 1.25, okay? If we took the square root of s squared and the square root of mu squared, we'll get something called s and sigma, which is the standard deviation. But this is standard deviation for the sample, and this is standard deviation for the population. But also, we have the row, so we can just put the square root here and get it, okay? So here s equal the square root of, and we put the same formula. So we end up with the standard deviation 1.29 and here 1.118. So this was the simple case where we have set of data and we want to get the mean of them. Okay, so I already got the mean of them, which is 1.5. I have got the variance with a sample or population, and I have got the standard deviation. This is straightforward case, and we can do it on the calculator. But in our case today, we have a data which is the variables and the probability of each of them. Okay, as we can see here in this example, it is not only the set of data. This is a discrete data. So the data here in my case can take only 0, 1, 2, 3. It cannot take 1.1 or 1.2. It is discrete data. Or 2.5, 2.7, anything. No, it cannot take any of these data, which is intermediate data between the numbers which we have. Okay, and also in this case we have the probability. So you find the set of data x's and the probability. So in the same way, we need to get the mean of this data, or what we are calling it the expected mean. Expected value or the mean. Okay, so we need to get the expected value or the mean of this x. It should be a number between this number, okay, because expected value should be something between, could be 0, 1.1, 1.2, 1.3. And this mean or expected value, it doesn't require or doesn't necessary to be a whole number or integer, okay, because it will be based on calculation. Calculation can give you any number, but the set of data which we have in our experiment is integers. Okay, each one of them is integer, so they are integers or whole numbers, but their mean or their standard deviation or their variance could be any number, okay, with decimals, okay, or fractions. So it doesn't matter, it doesn't mean that it must be whole or integer number. As we can see here, that 0 has a probability of only 0.1, while 2 has a higher probability of 0.4. Okay, 1 has a probability of 0.3, which is a high probability. 3 has a lesser probability, which is 0.2. So I cannot treat them if I want to get the expected x or the mean of x. Since I have the probability, it is not fair, they're not equally distributed. So I cannot say that each of them will have the same value or the same weightage. Some of them will have high weightage, okay, and some of them will have low weightage. It depends on the probability. With this one is likely to happen, it is 0.4 out of 1. This one is less likely, it is 0.1 out of 1. So in the case of the discrete data, if I want to calculate the expected value or the mean of them, I have different methodology. It will not be just adding up or summing up 0 plus 1 plus 2 plus 3 and divided 4. It will not be 0 plus 1 plus 2 plus 3 divided 4, because now I have probability of them, okay? So there is a different methodology to calculate their mean or the expected value. So it is called E, expected value of x, or we can call it E only, okay? But because the variable only is x here, so okay? So it is E or E of x, as you like to say, to write it. Just for simplicity, let us just write it E. So we'll use E. E equals the sum of px, okay? Pi xi. So if I have x here, it should be xi, okay? Just for the first example only, let us write it in full. So E xi equals bi xi. What does it mean? So x1, okay, 1, it will be b1 x1, E x2, it will be p2 x2. Okay, just to understand what I means here. Okay, let us do it and come back to our example. So it will be ex, okay, equal sum of bi xi. So if I want to get e of all these four number 1, 2, 3, 4, so e will be equal b1, the probability 1, times x1, p1 x1 plus p2 x2 plus p3 x3 plus p4 x4. So let us just practice on this example, so it will make it easier and clear to understand it. So okay, so here just I'll multiply hp by the corresponding x, it's x. Okay, so it will be equals the probability of the first one, it's 0.1 times 0, plus the probability of second one, 0.3 times 1, the probability of the third one, plus 0.4 times 2, plus the probability of the fourth one, 0.2 times 3 equals 1.7. Okay, so our expected value E, the expected value or the mean, okay, they call it expected value E, okay, or mean, okay, n of them will be 1.7. So let us look at the values of x which we have. We have 0, 1, 2, 1, 2, 3. I can guess that the value should be something in between here, okay? It could be, because the first one is 0. If I add this, will be 1 plus 2 plus 3 equals 6 divided 4. It will be equal 1.5. But it doesn't have the same weightage because some of them have a high probability and some of them has low probability, okay? So this is the way how we calculate the estimated value or the mean of the case of the discrete data where we have such x values and their probability. So if I try to present these probabilities which I have here, this probability on this numbering line here, so I can say that I have number 1, 0, 1, 2, and 3, 0, 1, 2, and 3, okay? The variables which I have here, x, the reading of the variable, 0, 1, 2, 3, and the probability 0.1, 0.2, 0.3, and 0.4. If I want to present them, so 0 will take 0.1 only. So I can draw here up to 0.1, 0 up to 0.1. 1 will take up to 0.3. So almost here, okay. 2 will take up to 0.4, which is almost here. Okay, and 3 will take up to 0.2. We assume that the mean should come in between, okay, should come here, but in reality, which was 1.5, but in reality, it didn't come to 1.5. Our mean was 1.7, so it is here, somewhere here, okay? Why? Because I have heavy weightage here. See, these are the big weight. This means like the center, okay, like the center. If you have a mass and you want this mass to be suspended balanced, so you have to carry it nearby to the heavy part of it, okay? So it will not be unbalanced to one side, okay? So that's why the mean always move toward the heavy weightage, okay? So here the percentage is 0.4 and 0.2, but here it's only 0.1 and 0.3, okay? So 0.1 and here 0.3, here 0.4 and 0.2. So that's why we have the mean here at 1.7, okay? Just this is for clarity to understand why the mean here we have used the probability, because not of them, all of them are equal. This one, we cannot say that 0 have the same weightage of the 2. 2 has a high probability it will happen, but 0 has a very low probability. That's why we have to multiply p by x, okay, or x by p. px1, px2, px3, px4, and so on. So it's called sum pixi. So here, coming to the main slide, the mean or expectation or expected value, okay, the average of the values taken up by the variable converge to this number if the experiment is carried out many times. So if we keep repeating the experiment, maybe the first time we'll have data here and there, then we'll have data here and there, then when we repeat the experiment many times, we notice that the data is converging toward a certain value. This is the value of the mean. And this is the value we are getting it through the probability. So here, this expected x, okay, E, what we have said, E, x, or E, or mu, we can use because this population, or mu, equals sum of pixi. Pi means the probability, so p1, x1 plus p2, x2, and so on. Plus, okay, this is the mu, or E. I hope this one is clear. If you remember, when we come to calculate the variance for the population, sample for the population, we said that sample is sigma square, which is equal x minus x bar square, okay, sorry, x minus x bar square, sum of them, divided n, okay, because it was sigma, it was not s, okay, so this was sigma. But in this case, if we have the probability, the scenario will be different. Sigma square in this case will not be x minus x bar, or sorry, here it is x minus mu, okay, because this is sigma, this is not s. If the sigma, we have to put mu, okay, sigma x minus mu square. So in this case, if we have the probability, the scenario will be different. Here it will be x minus mu square. Someone will say it is the same thing, x minus mu square. It is the sum of them also. Okay, so it is sum of x minus mu square. And it is xi, because x will take x1 minus mu, x2 minus mu, x3 minus mu here. But it is not divided by n. Okay, it will be times probability I for each one. So it will be xi minus mu, which is mu constant, mu the average or the mean, okay, square. All of this will be sum times pi. So let us apply this on the example which we have here. Okay, let us have the formula here. So I have mu from the previous example, it was 1.7. As we can see here, the mu was 1.7. So the first x will be 0 minus 1.7 mu, 1.7, this mu, okay, square. I have to get all of them. Every x, xi, x1 minus mu, x2 minus mu, x3 minus mu, x4 minus mu, okay. So 0 minus 1.7, the 0 minus the mean 1.7 times the probability, which is 0.1, plus 1 minus 1.7, okay, square, times the probability 0.3, and the same thing for the rest, okay, plus 2 minus 1.7 square times, let us put times so we're not confused, times 0.4, the probability, plus 3 minus 1.7 square times the probability, which is 0.2, okay. So the answer will be 0.81, okay. This is sigma square. This is called the variance, okay. So the variance is simply that x minus mu square, okay, times the probability. The second x minus the same mu square times the probability. So 0 minus 1.7 square times 0.1. 1, the second x, 1 minus 1.7 square times 0.3. 2 minus the mu 1.7 squared times the probability 0.4. 3 minus 1.7 squared times the probability. So this x squared. Okay, if I want to get x only, I have a different way how to do it. Or simply you can have the square root of, so x sigma will be equal to the square root of sigma square. I have sigma square here, it's already 0.81. So it will be square root of 0.81. So what does it mean if sigma is 0.9? Sigma, as we said, that we have to get the mean of the sample. The mean we have already calculated, it was 1.7. Okay, so if we presented the mean here, this is the reason I left this line graph here to represent this on them. Okay, so here this is the mean 1.7. I can add one sigma from this side, which is 0.9 to 1.7. It will be 2.6. Okay, so I can go here up to 2.6, and I can, this is one sigma, and I can take another sigma from the left side, so it will be up to 1.8, which is here. So one sigma from this side and one sigma from this side. So if you remember, we said that one sigma from here and one sigma from there, it will represent 68%. Okay, you remember 68% of the population. So 68% of the population is concentrated in this area, and it is reasonable and it makes sense. Okay, because most of the weightage are here and here. That's why all the items are concentrated in this area. So I have big gap here and also another small gap in this side. Okay, so we have already taken the first way how to find the variance, sigma square, and we said just it is the probability pi, probability times x minus mu plus the second probability times x minus mu, the third probability times x minus mu, the fourth probability times x minus mu, as we just listed. So it will be 0.1 times 0 minus 1.7 square plus 0.3, the second probability, times 1, okay, minus 1.7 square plus 0.4, okay, times 2 minus 1.7 square plus 0.2 times 3 minus 1.7 square. So this is the first way how to find sigma square. Okay, there is another way. Some people say it is easier, some people say it is more complex. So just for the purpose of sake of having it, in case if you like it and want to use it, you can also do. So the second way here is sigma square, just time multiply the probability. In all the cases, probability cannot be squared or cubed or get square root of the probability. Probability will remain the same every time. Okay, so the probability sigma square will equal 0.1 time you square x itself. Okay, so probability times 0 square. Then plus the second probability. Just let me clear this so it will be clearer. So the second one will be 0.3, the probability 0.3 times 1 square plus 0.4 times 2 square plus 0.2 times 3 square, and the answer of all of this will say minus mu square. So here we was taking every time x minus mu, okay, and so on, x minus mu. But here in this case we will not use the same way. So here we will use each probability times the square of x, x probability times the square of x, x probability times the square, and at the end minus mu square minus 1.7 square. So the answer will be 0.81. So also we can get the square root, so sigma will be equal to 0.9. Okay, I hope this is clear, the math. So let us go on through the slides. So here the slide says, so here in this slide we're done with the mean, and when you how to get the mean equal the sum of pi. Okay, so every probability time its relevant x. Okay, 0 times its probability, 1 times its probability, 2 times its probability, and so on. The second one here will be the variance, which is sigma square. Okay, some people call it d square or sigma square. We have two ways here. So the first way that will have x minus mu, 0 minus 1.7, 1 minus 1.7 square. Okay, 2 minus 1.7 square, and so on. And every one of them times the probability. So 0 minus 1.7 square times the probability. 1 minus 1.7 square times its probability. 2 minus 1.7 square times its probability, and so on. This is the first way which we have taken. The second way was just the sum of p xi square. The probability time is x square plus probability of the second one times x square, probability times third one and fourth one. After we getting all the sum, we will subtract mu square. Okay, so this is called variance. If we get the square root of this variance, it will give us the standard deviation. So standard deviation is the square root of the variance. Okay, example of rolling dice. Just here how to calculate the mean and how to calculate the variance. Okay, variance, which is sigma square, and the mean. So the mean, as we say here, it will be everyone. So I have x equals 1 because it's a dice, fair dice. 1, 2, 3, 4, 5, 6. So every x times its probability in order to get the mean. So 1 times 1 over 6, okay, or 1 over 6 times 1, 1 over 6, a second probability times 2, 1 over 6 times 3, 1 over 6 times 4. We add all of them up, okay, so we'll get the total or the mean or the expected value, which is 3.5. As you know that the dice doesn't have 3.5 on the faces. Only 1, 2, 3, 4, 5, and 6. All are integer numbers, okay, whole numbers. But for the mean, there is no issue at all to have the mean as decimal, okay? So 3.5, or has a fraction, okay? Sigma square, if we use the second methodology, okay? So here we have to multiply. Okay, so you have to multiply each probability by the square of x, okay? So 1 over 6 times 1 square. 1 over 6 times 2 square. 1 over 6 times 3 square. So each probability by the relevant number up to 1 over 6 times 6 square. Then all the result, after getting all the results, minus mu square. In this case, mu or the average was 3.5. Okay, so minus 3.5 square. So this is the variance. Okay, it is not the standard deviation, it is the variance. If you want to get the standard deviation, we have to get the square root of sigma square. We'll get sigma. Okay, which will be 1.7 in this case. I hope this clarify this mean and variance of discrete random variables, because it is little confusing with the previous traditional one for only a set of data without probability, which we have taken in the previous video.